Welcome to our webinar on optimizing grid planning and operations with high data quality. You will receive valuable information designed especially for power utility professionals, such as protection engineers and operation engineers, who are looking to improve the grid data management process and enhance operational efficiency. My name is Sarah Estarabadi and I'm happy to be your moderator for this webinar. We will start with the current challenges and changing needs in grid data management. Then we will learn how to improve workflow efficiency and consistency. Because data quality is key, we will see how to enable data validation. Afterwards, we will have an example case about how to optimize data management in protection departments. Finally, we will answer some of your questions. And since we receive one question rather often, yes, we will record the webinar and make the recordings and the slides available to all participants. If you already joined one of our last energy automation webinars, you already know the Q&A field on the upper right side in this application. Please type in your question to the presenter and I will be your voice and ask Maiko directly after his presentation at the end of the session. Questions will be answered via email if not managed during this session. And just in case you are in full screen mode, press Escape to see the Q&A and the chat box. Now, let me introduce you to our expert. Maiko Friedrich is a senior consultant with more than 8 years of experience at Siemens AG in the energy sector. As part of the technical consulting team of Siemens, he covers a wide range of consultancy services. Maiko is an expert for the power grid strategic planning and therefore familiar with the challenges of the energy transition, with flexible and automated data management, with optimizing workflows, and with improving data quality. As a grid data consultant, Maiko has become an experienced energy and technology data analyst and knows the best practice grid data modeling methodologies, management concepts and data verification practices. Maiko, the stage is yours.
Thank you, Sarah, for the introduction, and also thank you to everyone here who joined the webinar for having the interest in this topic. Today, I want to try to make you rethink your grid data management concept with the special focus on increasing the data quality of your daily operation to optimize your daily work and save money and time. I want to start with a statement. Some years ago, the Harvard Business Review have done some studies, and they said, or they have the result, that 80% of the analyst time is spent simply discovering and preparing data. For me, as a power system consulting in the project business, I can confirm this. Every time on my studies, in the first time, I have to collect a lot of data, verify the data manually, validate it, and So in the future, it will be even worse, because with the rapid digitalization of the energy infrastructure, some new challenges arise for all of you, for all of the power grid operators. You need to define a long-term digitalization strategy. On the other hand, more and more tools have to be integrated in your system, and also data silos with new information from new sources have to be integrated and validated. As a next step, another issue is the harmonizing of data transfers between business units. You cannot focus on your own daily work, but you also need to focus on other departments, on your colleagues, on other business units, what purposes they have, for what purposes they need their data. Moreover, hence, all the data, all the grids are getting more and more intelligence. The amount of data is growing significantly in the next years. As an example, 90% of all data which are currently available was created in the last 2 or 3 years. And this increase of new data is expected also in the future. To be able to tackle all these named challenges, an efficient and future-proof data management concept is necessary for all of the power grid operators to be able to have reliable data and results you can trust for your studies and for your daily operation of the network. Also, it's necessary to have a good collaboration across domains and have an easily and agile data management concept to be able to integrate new tools and new data silos. But on the other side, how is the current situation at all or the most of the power grid operators? In the past, there were not many efforts to think about optimizing the grid data management concept. All the different departments are focusing on their own purposes. They are manually maintaining their own model of the same physical grid and keeping track of implementing new changes on their own. And each process of data exchange is combined with a cumbersome and inefficient manual process. Fragmented data is then shared across all domains via different formats, via SharePoints, via email, via Excel, via PDF documents, which is very hard to trace back so that you, after a while, cannot find where the results are coming from. And on the other side, there's also the danger that in the same company, the same information is stored in different locations, but with different values, so that a lot of mismatches between the values can be seen. And this all results in an unknown level of data quality in all of the departments, which need to be addressed in the future. This inefficient data management concept results in an unnecessarily wasted amount of time and money. Here on the slide, I have given you some exemplary numbers based on different studies worldwide. These numbers are mainly coming from process inefficiencies or the manual data collection and manual data validations. As you see, there are a lot of issues which can pop up and a lot of challenges will become even more important in the future. So it's now time to rethink your data strategy. To do so, the way to take control of your data can be separated into 3 blocks. The first block is to analyze your existing system. Then go to the concept design, where you want to go in future. Afterwards, it's time to ensure the data quality of all your involved data blocks and softwares and business units. Let's have a bit more detailed look on the analysis of existing system. In the beginning, you need to know where you are. So who is taking care of which data? Who is changing information with other departments? Who is taking control of them? Who is updating the data and when? So if you have a very close look on the as-is situation, you will very fast identify some pain points, which always results in delays and some discrepancies of data. And if you do so, you will in the end get a transparency on all the data requirements you and your business group have and can tackle the pain points you have currently. And to tackle the pain points, then you need to derive your optimal concept afterwards. So if you, so with the concept design stage, you need to define your optimal data management concept for all your individual needs you have in your business unit, in your department, or for your single use case. You define optimized workflows, optimized interfaces, and data formats. And in the end, you will define a concept design which addresses all your needs and minimizing thereby your cost and increase your efficiency for your daily work. Last but not least, as a third step or third modular approach, you need to ensure your data quality continuously. Data quality is not a state you can reach once and for all. It is an ongoing continuous process. And data quality itself you need to understand it's more or less separated into 3 blocks: data consolidation, data verification, and data validation. I will go a bit more detailed to these 3 topics later on this presentation. In the end, with this modular approach, you will get a transparency on your data quality and so guarantee your long-time success for projects and studies. Yeah, now let's have a more closer look at the analysis of existing systems. So one step back. So first of all, as I said, you need to analyze your existing system. So added here exemplary some of the questions you need to ask yourself is, for example, which standards need to be met? Which tool do I have in use? Which formats are available for exchange to other colleagues, to other departments? What is the level of my data quality? How often do I revise my data? And also which data models or data sources are available to integrate in my current system. And as you see, these are only some of the questions you need to take care. And every power grid operator has some individual system requirements, so that there's no one solution for all, but it's always an individual concept. Here I have an exemplary existing system for a protection department. Of course, this is only exemplary because it's an individual solution for all of you, and the software structure, the department structure can derive or can be different at different companies. Nevertheless, based on my experience, I tried to get a well-known structure, which I have seen quite often at transmission system operators in this case. So here in the middle, you see the protection department. The protection department normally is using one protection simulation software, for example, the Siemens solution PSS SynCal or PSS Cape. Then, as you see here, all around the protection department, there are several other groups the protection department has to interact with. For example, there's always or has to be always an exchange of information with the planning department here on the right side, where all our new primary equipment data is exchanged. On the top work, you see some field engineers who are collecting as-built information or who are setting up the protection settings in field. Also, some external partners like the upstream network operators are in contact with the protection department. You see it on top right side to, for example, exchange new or updated short circuit level values. As you see here, there's a lot of different partners and a lot of different co-workers for one protection department, and all need some special interfaces in different formats. In this slide you can see I have named, for example, PDF, Excel, and some manual formats here. Yeah, and here, by analyzing the existing system and also talking to the different partners here of the protection department, you will then identify some pain points, which normally result in some delay in the projects, which results in some mismatches of information, and maybe also that some information are completely missed at all. Here on the left side you see, for example, the GIS team, the Geographical Information System team. They have all the information, the geographical information of the power grid network, but the existing system don't have so far interconnection of the GIS system to the protection simulation software. So if you would have been some automatic update of data between the GIS system and the protection simulation software, it would help you quite a lot to integrate up-to-date data and avoid a lot of manual work, efforts and time. Also on the right side, I have marked some other examples in orange, which can possibly be addressed, mainly some automation issues and also always think about changing formats to a more editable format or automated format. In a next step, based on the pain points you have defined, you then need to think about the right individual data management concept for you, for your business, for your department. The main tasks you have are to optimize the workflow, to optimize the data exchange, to prove also the availability and the actuality of all the relevant data you need for your purpose, and also to ensure the data quality. Moreover, you need to enable a company-wide data handling concept so that all of your departments are involved and are involved in data management concept. Yeah. The outcome of this would be that you will have minimizing cost, higher data management quality, and also higher operation efficiency. And this will affect all of your daily work of the power grid operation, of the studies and the planning. Here, you remember 2-3 slides before, I had the as-is situation of the protection department. Now we changed it a little bit to address mainly the pain points, but also to address some, to optimize some of the other workflows here. For example, on the left side, there's still the GIS system team, but now there's a regular update from the GIS system towards the protection simulation software. And via an automatic export, a one-click or at least with a few click solutions. Then between the protection simulation software and also the protection relay engineering software, you see now another green box with the protection data manager. Here, with integrating a protection data manager, for example, the Siemens solution GridScale X PDM, or any other protection data manager, you are able now to do automatic data exchange between the protection simulation software and the relay engineering software itself. So it avoids our manual data exchange. And each manual data exchange can result in any data mismatches or errors. On the right side, you can also see a bit different structure. Mainly all of the single point-to-point connections where data has been exchanged via unstructured SharePoints, PDF documents, Microsoft Teams SharePoints are also restructured a little bit. And also what is very important quite often is that also the field engineer now has a defined process that the as-built information is on one side going back and integrated into the planning department, and the planning department is also sharing then the as-is information to the protection department in the end. Another part of designing a data management concept is thinking about if you want to stay in the app-centric approach or if you want to move maybe to a data-centric approach. Let's have a look what are the differences between these two approaches. On the left side, you see an exemplary scheme of the app-centric approach. In the app-centric approach, the overall data management concept is application-focused, and the data is silo-bounded. That means there are only point-to-point connection between the different tools or application you have. This concept is currently the main tool landscape worldwide due to the buy, not build approach, which were mainly focused in the past years. Yeah. On the other side, let's have a look on the data-centric approach. In the data-centric approach, the data is now the primary and permanent asset in the middle of the data management concept. And the data is not longer tied to application, but the tools or the application are generated around the data. There you have now a flexible concept with the data in the center, and all the tools around are integrated to a so-called single source of truth, which stores all the relevant data for all the different tools. And you have then a point connection from the single source of truth to the tool you are using. Yeah. Yeah, for both approaches, you need to think about what to do to optimize the processes. If you want to stay at an app-centric approach, then you need to optimize all your processes of data copying and storing. And also, all single tools need to be optimized, integrated. Moreover, as mentioned before, you need to raise a company-wide awareness of all the data needs and purposes of other departments. If you want to move to a single source of truth data-centric approach, then you have some other challenges. For example, you need to ensure that you have a consistent data annotation in all of your tools and all of your data sources. Because in the end, all are linked together. And you need to define or integrate a single source of truth. So one base storage of all your data you have. This can be an external product, for example, the Siemens tool PSS ODMS, or you can or some other vendor products. And yeah, you also then need to verify the integration of all tools into the data-centric approach, into or to the single source of truth. Here you see now an example concept design, again for the protection department, but now not as the application focus, but for the data focused approach. In the middle here with the green box, there is our single source of truth, for example, the PSS ODMS. This single source of truth contains all data of all different domains. So it has the asset information necessary for power flow or short circuit. It has also the information about the protection systems, the protection relays, including their settings, or also the geographical information data, and also some further planning information from the planning department. However, not everyone has access to all of these data. Only to the relevant data, but only to the relevant data. The GIS team can upload all the geographical information data, but they don't have access, for example, to the planned structural changes of the planning department if it's not necessary in the process. So. And also on the other side, let's focus on our protection department. You see on the top, there are still the 3 tools from our protection department. On the left side, the protection simulation software. On the right side, the protection relay engineering software. And on the top, the protection data manager. All of these 3 tools have interfaces to each other, yes, but the data are coming from the single source of truth and also from the relevant part. So the protection simulation software can have access or does have access to the power flow and short circuit data like load profiles, customer loads, whereas, for example, the protection data manager now has access or can grab the data, all relevant for the protection. Okay. In the last slides, I exemplarily took a protection department. Of course, the analysis of the data management concept can also be performed or should be performed for the planning department, for the operation department, or for the operation planning department. Each of them have different purposes, different workflows, but all of them are working with grid data. Yeah. However, each department, the workflow of each department is just a huge number of different workflows of different use cases. So in the end, you always need to look at one specific workflow, at one use case to optimize this use case. In the next slides, I will give you a short demo of one use case which you can analyze here. But also, moreover, you can go one step higher on a whole company level. So to derive a whole company approach where all departments of a company are included and also the overall company data management concept is analyzed. So as discussed, as named, I want to go on now with a single use case of a protection department. Yeah. In a protection department, there are several different use cases in your daily life, or also which can pop up quite regularly, not daily, but maybe monthly, every year, and so on. I just have named here some of them. For example, here in the top, Sandra, the protection system modeler, has the questions: I have to update a protection model based on a new planning model. On the right side, I also have given some network planning use cases. Patrick, for example, I have to transfer my existing power grid model to a new tool, though it looks like they want to integrate a new tool in the existing tool landscape. And also he wants to integrate GIS data as basis now for all the network planning studies, and he's asking how to do so. I think all of you can add more and more use cases in these questions, depending if you are from the network planning or for the protection department. But hence I don't have the time here to focus on all of them. I just picked here the first question of Sandra, which is: I have to update the protection model based on a new planning model. So let's have a look how this is currently mainly solved in the power grid operators on a transmission level. I say it's mainly. It's always, again, an exemplary use cases, which is quite often still in place. So in the beginning, for example, you have a transmission planner from the planning department. I named it here Peter. He is updating a planning model in the first step. In the next step, he is sharing then the new updated model via PDF, for example, to Sandra, which is the protection system modeler. And then Sandra is manually reviewing the receiving information from Peter, is identifying the changes, and then is manually transferring the changes to their own power protection department model. So the issue here is that the transmission planning team as well as the protection system modeling team have two different software tools with two different grid models. Then in the next step, after Sandra has updated the protection model, she is sharing the updated protection system model, for example, via mail to her colleague David, who is responsible for setting up the protection setting. David updates now the protection data of the protection system based on the new model, on the new asset data, for example, and then is sending the revised relay setting in the end to Susan, who is the relay setting supervisor, and just do another manual verification of the received settings. Last but not least, Susan is then sending the report or the setting report to a field engineer called Patrick in this case, who is then finally implementing the updated setting into the field. Yeah, you've already have seen the issues. In these steps, there are a lot of manual update processes. The network model is updated manually, the relays settings are updated manually, and each manual update is a time-consuming process with multiple steps. And last but not least, there's also no documentation, or the documentation is at least not sent back of the implemented settings to David or to Susan to verify that the settings have been implemented correctly. On the next slide, we have an example here how maybe this use case can be optimized. And yeah, in the beginning, you still have Peter, the transmission planner, who is updating the planning model. However, the next step, the updated planning model is not shared via email, via PDF, but is, for example, shared directly with a point-to-point interface between the transmission planning tool and the tool Sandra is using for the protection simulation modeling. Yeah. Can be, for example, with the PSSE format. That means Sandra can now automatically import the newest planning model into the protection system model and don't need to collect all the changes manually. In the next step, David then updates the protection data of the protection system model after Sandro has prepared the model. And he's then sharing also via, for example, some Dixie formats or TX formats, Excel formats, all the relevant setting to Susan, who is then manually verification the settings. So this manual verification, unfortunately, I think is still necessary in the future. However, in the next step, Susan is then also sharing the setting report in an exchangeable format to Patrick, ideally directly to the protection software engineering tool like Dixie. And then Patrick can implement the newest updated setting into the field and traces back and forward back also the implemented settings to Susan, who can then check again if the implemented setting have been correctly performed, have been correctly installed. With this process, there are still a lot of parties involved, right? But nevertheless, the manual efforts have been reduced quite a lot. This results in an increased accuracy and especially saves a lot of time. Yeah, now I had a talk to you to focus on a specific use cases, so on a very deep level. And now let's go 2 steps back. So not focusing on department, but focusing on the overall company. Also for the overall company, it should have been a global approach to analyze the system and derive a concept design, and last but not least, ensure also the data quality of your overall company with all the departments involved. I also have given here an exemplary structure of power grid operator company. You have a protection department, operational department, planning departments, JS team, customer relationship teams. Of course, this is again an exemplary use case, and especially because it's very exemplary and the overall company structure is really an individual solution. I want to stay here in the analysis of the existing system and don't go deeper into the concept development phase here. But you see here that the overall picture, which is necessary to understand the purposes of each department, you will see which department is, which relevant data is needed by each department and where the data is coming from, who is responsible for which data. And so with the big picture, you're then able to derive an optimal individual concept for you and for your overall department and for all single colleague for yourself. Now, let's jump to the 3rd step. We have now discussed about the analysis of the existing data management concept for company, department, and also single workflow. We focused on optimizing the concept design, and last but not least, you need to ensure the data quality of all your data you are using in the daily working day. But in the beginning, we have to ask the very important question, how to define data quality? What is data quality? What is bad? What is good data? How can you classify these data in good or bad data? So for example, which KPIs are needed? In the beginning or historically, if you have not implemented any data quality checks, you will start with a very high uncertainty of level of data quality. You see here in this diagram here. So you cannot name specifically which level you have of data quality. On the other side, you also need to aware that data quality consists mainly out of 3 parts. So data quality on the one side is the data verification. So you need to have a data consistency between different departments, between different software products, between different data models. Also, data accuracy has to be fulfilled, as well as the completeness of data in all of the models. On the other side, the second part is the data validation. You need to ensure that all the data you are using is meeting certain standards, limits or criteria, for example, via some defined validation rules. And as a third step, the data consolidation. Every time you are mapping new data into your grid model, you are adding new uncertainties to your data model, which then need to be checked once more. So let's go to the next question. How to assess data quality? Keeping now the slide before in mind that data quality is part of data validation, verification, and consolidation, you always need to make sure that these three steps are defined. So let's start from the beginning. So if you start with a Power Grid model where you have an uncertain level of data quality, if you now do some data consistency checks or validation checks, for example, based on standards, based on physical limits, or some of your experience-based ranges of values, you can then derive a more specific level of data quality. And in the end, you maybe don't need that high safety factors for calculation or also for the dimensioning for your assets. Some validation rule examples are listed here. Also we sorted them into three levels. The first level is the primary asset. So really the single values of all your equipment. And you can check these now. Are these values according to standards or according to manufacturer limits or physical limits? Or if you know that you always have one specific transformer type in your network, you can also check for typical customer assets in this case, and maybe identify that the data for one transformer is maybe not identical to all of the other transformers in your system, so that you can have a closer look on this transformer and can see, can be an issue with this transformer. On the next, the second level, you can also check the primary system interconnection. So for example, are there any isolated points or areas in your network? Normally should not be. Or are the nominal values always at the connection points the same? Does the transformer rated power fit to the connected downstream load, for example? Does the ratings of the line fits to the connected current transformer of the protection relay? These you can check here with the primary system interconnection rules. As a third level, we have the primary and secondary system, which can be validated to identify any cross-correlation over your overall system, so that you're not only focusing on one asset, on the neighboring assets, but also on all the assets you have in your system. And here, in the next questions you need to address is how to increase data quality continuously. Adding, as explained before, adding new data is always adding uncertainties. So you need to define or implement a continuously data consolidation and data validation to maintain your data quality. On the next slide, I have given you a bit more detailed example here. So in the beginning, here on the diagram on the top, you have an uncertain level of data quality. After a while, you get, for example, some new data from the planning department, integrates in your system, but because the planning department data is also not validated, during the data update processes, you very probably will lose some data quality. And step by step, with manual consolidation, you can then find you can then increase the data quality to its initial level again. But as you see here, this is again a manual consolidation, so quite often you won't find all issues, and nevertheless it's still very time consuming. On the other side, let's have a look on some automated data verification and validation concepts. So if an automated data verification and validation is implemented, you can start here on the left side and test and do a data quality check on your currently level of data quality, and you will then see all the mismatches you have in the system and can increase it. And also what is very important here, you know then the level of data quality you have. You have a specific level of data quality which you can then use for your calculation, for your planning, for the protection design. On the right side, you also see another example with a data update. So it starts again with an uncertain level of data quality. After a while, you get a data update again, for example, from the planning department. You integrate the information in your system, and then with an automated validation check, you can increase the data quality on both systems and gain a specific level of data quality. All in all, if you ensure data quality in all your concepts, it will get you the transparency of the level of data quality you have here. It will improve the data verification itself, will improve the data quality, and any automated data consolidation and verification will save you time and cost in the end. So I hope that I could highlight now the importance of data quality with my presentation here. In the next few slides, I want to introduce us, PTI Consulting at Siemens. So we are from the consulting team of Siemens, and we have two groups here in the PTI Consulting team, the Energy Business Advisory and the Power System Consulting team. The Energy Business Advisory is a global expert team of PTI dedicated to strategic management topics. For example, we support and consult you for digitalization strategies, for cybersecurity issues, or to derive the optimal e-mobility strategies for your company. The other Power System Consulting team is focusing for all the technical issues which can arise when operating a power grid. For example, we consult you in the power system analysis and design and help you in the grid modeling as well in the data consulting. With the right model, we can then focus on the interconnection of renewables and do some system dynamics and transient studies. Also, we have experts for other topics like power quality, protection, control and automation, as well as a laboratory for the real-time protection simulation and testing. Yeah. We from PTI are a worldwide team located in 20 offices worldwide. Our headquarters is here in Germany, but as you can see, we have also strong teams located in USA, Turkey, South America, Australia, and further countries worldwide. And all in all, we have around about 250 experts consulting worldwide. We from PTI can now accompany you on your journey to taking control of your data. If you remember, in the beginning of the presentation, I have said to tackle all the challenges from the ongoing digitalization, the first step is to analyze your existing system. Here we can help you to identify all the ineffective data management in place. In a workshop, we will understand together with you all the needs you have, all the needs which will pop up maybe in future, where you want to go in future, and which tools and which data you need in a good quality format to achieve this. In the next step, we consult you in the concept design. We can consider together with you how a new approach to data management could empower your people and supports you in adopting an optimized approach. Last but not least, hence our colleagues are on the one side energy experts, but on the other side also data experts. We can help you increase the data quality by defining individual data verification and validation rules for all of your Power Network models, and check with you together that the consolidation between all the involved parties, tools, and so on. All in all, I want to highlight again that with an improved data management concept, it will directly affect the security, the quality, and the reliability, as well as the availability of supply for you as a power grid operator. So we, from the Grid Data Consulting team, are always focusing on the individual, to develop an individual concept to tackle your individual needs. Moreover, we are, of course, part of Siemens, but nevertheless, when we are searching for vendor-agnostic solutions and help you to identify your optimal concept with the current using tools, but of course, helping you and maybe optimizing your tool landscape with other products. Moreover, we can support you in integrating an optimized data management consolidation across different domains. And we are focusing to get a high flexible against structure changes for you and your system. I want to close my presentation today with a question to you. Are you faced with project delays due to cumbersome data collection and inconsistent data sets? If so, try to address them to save money and time in future. And also, we would be happy to support you to solve these questions. Thank you very much for your attention.
Thank you, Michael. That has been an interesting session with insights into optimizing system planning and operations with high data quality. Let me check for questions from the auditorium. I will read each question out loud and you can then answer them. The first question is, how do you perform an automatic data validation of a whole power grid model, and can you consider customer-specific specifications?
Good question. Thank you, Sarah. As mentioned in my presentation, the main focus is not to do validation manually, but to implement somehow an automatic approach. We from Siemens PTI have developed some internal tools to be able to import power grid models and to do automatic validation checks on these models and to be able to see the violation of these rules immediately. And also, in this validation engine, we are able to integrate customer-specific rules and checks to get an individual solution.
Mm-hmm. And if I have a project, what is the expected time frame for a grid data consultancy project?
Mm-hmm. Yeah, right. So in the first step, you need to define what kind of grid data consulting project you want to have. As I highlighted in the presentation, it can be focused on a specific use case, it can be focused on the whole department, or even on the overall company level. And of course, depending on this level, the time frame of a consulting project varies quite a lot. On the one side, if you just look on one specific use case, this can be analyzed and a new concept can be derived very fast in a few days. Whereas if you look on the overall company level, a lot of different departments have to be involved. And this is now a very individual concept. It takes, of course, a bit more time here.
Mm-hmm. So if I want to increase my data quality, what is the best way for me to start?
Yeah, the best way is to ask yourself, what data are you using in your daily life and where is it coming from? And also focus, so if you always have to ask, or if there's always some delay in getting these information and you always know, okay, you have to manually update these and these data as at these points, focus that you can update this process in advance to to increase the quality of your daily process. Yeah.
Okay. Can you name some successful transitions from application-centric to data-centric approaches which you have had?
Yeah, okay. But before I name some, let me explain. In the presentation, I named that there's two data concepts, one the application-centric and also then the data-centric approach. It's not mandatory maybe to move to a data-centric approach, but of course the data-centric approach has a lot of advantages, as you have seen in my slides before, in my presentation before. And these transition to a data-centric approach, we as PTI have, for example, accompanied with some worldwide TSOs together with our software colleagues from Siemens GSW to implement, for example, PSSO DMS.
Great. Okay, let's have a look at the next question. To face all challenges of the digitalization, do you mean it's necessary to change all of our current implemented data exchanges, like Excel sheets or email exchanges?
Yeah, right, a good question. Of course, I know due to historical issues, the data exchange processes have developed to a very complex structure, as I have shown you in one of the slides in the beginning. And it should not be the overall goal to automate everything, but at least you should keep in mind where you are at the moment and where you want to go in the future, and to try to solve all the needs you will see in the future with a new changed automatization data management concept.
And if I want to work with PTI together, do you support also in developing new software interfaces?
Yeah. Unfortunately not. Yeah, so we are from the consulting team. So of course we are energy expert and data experts, but for the IT, we don't develop new interfaces here. We analyze and evaluate the software interfaces between each and other and check if the data is complete and consistent between these two. But we can unfortunately not support you here in developing new software, at least not we as PTI, but we have other Siemens colleagues which we can involve here.
Great. Thank you very much. That was the last question. Dear auditorium, thanks a lot for your questions and thank you to Maiko for all your answers. There are still many open and very good questions in the Q&A queue. To limit the Q&A part, we will answer them via email. And if questions come to your mind later, please contact our specialist. I'm sure they will get back to you soon. The access to the recording is automatically available to all participants directly after this session with the same link you got for the live webinar. Thank you very much for your active participation. It was a pleasure for me to guide you through this session. Take care, stay safe and sound. See you next time. Bye.
Bye-bye.